Hi, my name is Chen. I'm working as senior database engineer at Bilibili, and today we're going to talk about MariaDB at Bilibili. A talk focuses on how we use MariaDB at Bilibili and MariaDB architecture at Bilibili, and how do we make database formation, scale up, and so on. And first of all, I would like to introduce what is Bilibili and what's major business. Our website is www.bilibili.com. And Bilibili is one of the most popular websites of China. It's an online entertainment community for young people, and it's a free video sharing website, which makes it easy to watch some online videos. And instead of videos from major TV networks and movie studios on Bilibili, you will find something special, just like animation and comic, gaming, and study courses, and all kinds of amazing and creative videos made by some young people just like you. And you can even create and upload your own video to share with others as well. Moreover, we have live streamed e-commerce, gaming, and so on. And we have more than 170 million active users every month. Okay, here you can see, here is some screenshot for Bilibili website. You can try to go and find something interesting. It's more like a little YouTube of China. Okay, so here is why do we use MariaDB instead of Mysql. That is because MariaDB is made by the original developer of Mysql and guaranteed to stay open source. And MariaDB does not have closed source modules just like the ones in Mysql Enterprise Edition. So it's built upon performance, stability, and openness. And MariaDB Foundation's ensures contributions will be accepted on technical merits, and also MariaDB supports some more important storage engines such as Aria, Spider, DB, and so on. Also, it has a lot of great features such as thread per, faster and safer application, instant auto tables, and so on. Okay, here's how do we use MariaDB. Where do we use MariaDB? We use MariaDB for user informations, member and relation data storage, and also for website, API, and authentication request, and almost all the metadata with videos, live stream, gaming, and so on. And also, for some store, for some e-commerce orders and payment information in MariaDB. And basically, it's used almost all business units of business. And what's more, all sensitive data are encrypted to protect privacy, so it's very important for our users. Okay, so this is the situation for MariaDB at Bilibili. We have several data centers for business requirements and disaster recovery, and solid MariaDB servers, and there are managed by automation system we use Ansible for server management. And also, we use GTID for MariaDB replication management. And all of the production MariaDB servers are 10.1 and 10.3. And we are running with max 45k QPS for single instance. So you can see maybe we're not for large, but very busy. Because we have live stream business. In case of some popular export computations, the online room concurrence will be several millions. So which makes a lot of service traffic at a very short time. To the next page, we are going to see what we DBA team are planning to do next step. Okay, the first thing is to migrate database to the containers such as Docker, because it can make it easier to run multiple MariaDB processes on the same host in different versions and configuration, and also better for resource isolation such as CPU or I/O. The second plan is upgrade MariaDB server to 10.4 and 10.5. MariaDB has some more great features in 10.5, so that's why we're going to upgrade. Okay, the next step is to more automations We have already made some automations as of now, but it's not enough. We're going to plan more, such as upgrading the base and restart the base. Okay, and also we are going to make the base health report with tuning advice, with some tuning advice automatically. Okay. Okay, here is the base architecture at Bilibili. Basically, every cluster is running on 3 descenders for the purpose of business requirements and disaster recovery. And also we use single master, and other slaves are using GTID replications. So we have a system named Access Server to perform database provision, switch over, replication, manage, and so on. And also we have database proxy for service traffic forward, database topology discovery, and read and write traffic split, connection port, and SQL blacklist. A proxy is set command and running with application containers. So by proxy, we can do something such as the database migration very easily. Okay. With the rapid development of business, DB had to do more and more SQL reviews and execution tasks. So it may take a lot of time for DBA. And so we have automation system for some repeat tasks, such as hardware and database provision, and automatic database backup, and table structure audit, and data modification, execute safely, and online schema change. For online schema change, our system will use GHOST to perform online schema change automatically. And also, the system can provide the SQL tuning advice automatically. The developer can import the SQL, then he will get the tuning advice such as index tuning and so on. Also, we had made some automatic recovery from some failure. And for example, hardware crash, and PCA asset debug detection, and replication delay recovery, and it will downgrade the InnoDB, redo and binlog flash level for from 11 to 00, and so on. And also for the business traffic to some other slaves with no replication delay. And all of these are automatically. Okay. Here's the workflow for our self-service system. It had saved a lot of time by automation. Okay, Skype read. Export is very popular among young people, so there will be a lot of traffic during some export computation on live stream rooms. So, Scale up reads mostly is very important for Bilibili. So, we use automation system to create a new instance and load data from backups and configure replication. Once it's ready, and we will perform some warm up, and the proxy will detect new slaves and make a reband for slaves. We can set some traffic forward wait for every slave. Okay, finally, I will subscribe how do we make switchover. If we use some replication tools for switchover, such as MariaDB and so on, it will run several seconds with service outage, because you need to set a master to be read-only and then wait the new master to catch up with the replication. Okay, and so we are using a different way for switchover. The first step is to change the application topology from master to master. The second step to reset global variables, automation increment and offset, aim to make automation auto increment for old master going to be odd numbers such as 1, 3, 5, and new master to be even numbers such as 2, 4, 6. Okay, so next step is to kill persistent connection on old master, then the proxy will handle the connection automatically. And the fourth step is to switch over and change the application for slaves by automation system. The proxy will detect the new master automatically. Okay, and the fifth step is to perform the health check, and then change all the master to be a slave and read only. The final step is to rollback the increments and offset to 1 for global variables. Okay, that is how we perform switchover for production. So we are approaching to end of my talking, and thanks for your interest and attention.